Hi there, it's Diane. Welcome to my basement. Today we're going to be talking about fractions, and then we're going to compare fractions. Before we get started, I'm just going to let you know that we're going to hear a lot of new vocabulary words. Some of these words are going to sound really difficult, but don't worry about it. By the end of this, you'll understand what fractions are, and you'll be able to compare them. Let's begin. So, open your book to page 78. Great. Fractions. A fraction represents one or several equal parts of a whole. This whole can be a single object, we call that an integer, or a group of objects, which we call a collection. A fraction is composed of a numerator and a denominator. So all you really have to know is that the numerator is the top part of the fraction, and the denominator, think of the word down, is the bottom of a fraction. We know that 1/5 is a fraction because it has this line in between the two numbers. For the fraction 1/5, we see that you can have a whole, and here the whole is a circle, and it's divided into 5 equal parts. Let's count. 1, 2, 3, 4, 5. So one of the 5 whole parts is shaded. 1/5 is shaded. Here with the collection, we have a collection of 1, 2, 3, 4, 5 dots. One of the 5 dots is shaded, so 1/5 is shaded. Does that make sense to you? A fraction is with one number divided into another number. So the 1 is 1 out of every 5. I like to say out of for this line, so you'll see what I mean. If you look further down the page, you will see 1/2, or 1 out of 2 equal parts. So we have 2 parts of a cupcake, and they're equal. They have exactly the same side, right? The right looks exactly like the left. So 1 out of 2 equal parts. Or if you have 2, let's call them, they look like Smarties here in Canada, don't they? So we have, or M&Ms, but there's no M. So 1 out of 2 candies is circled. 1/2. It's really important to know that they have to be equal parts. Let's look at 2/3. So 1, 2 out of 3 pie pieces has been circled. 2 out of 3 candies has been circled. We say 2/3. So here you can say either 3/4 or 3/4, because we all know that 4/4 equal $1, right? 4 just means a quarter, or 25%. I'm throwing a lot of information at you, I know. Some of it will stick today, and some of it will make sense later. The more I tell you, the more you know. So let's continue. 3/4 means that 1, 2, 3 out of 4 whole pieces has been circled. Here 1, 2, 3 out of 4 in our collection has been circled. 3/4 or 3/4. And here we have 5/6. 1, 2, 3, 4, 5 equal parts has been circled out of a total of 6 parts. So the whole is 6 pieces, and we've circled 5 of those pieces. In our collection, we have 1, 2, 3, 4, 5 out of 6 whole. 6 is our whole, right? 6 whole candies. 5, 6. I hope that makes sense to you. Let's practice. Sometimes just practicing helps. Let's look at page 79. In the fraction 1/2, the numerator is, which number is the numerator? 1 or the 2? If you think it's the 1, put your thumbs up. If you think it's the 2, put your thumbs up. The numerator, you're right, is number 1. It's the number on top. It's the part. The denominator is the number that is down. It is underneath. It is how many total parts there are. So 1/2 has 2 equal parts, and 1 of the 2 parts is what you have, or is shaded usually. In the fraction 3/4 or 3/4, the numerator is, just say it out loud. Excellent! It's 3. And your denominator is the number that's at the bottom that tells you how many equal parts in all. What did you say? In the back? Oh yeah, 4! You're right. Great job. Ooh, this is a little tricky, but I know you can get this one. In the fraction, so now we have to write the fraction. The numerator is 5, so the number on top is going to be 5, and the denominator is 8. So 5 out of 8. Now, can you just put a 5 on top of the 8, or do you need something between the 5 and the 8? Yeah, you need that little line. So 5/8 is 5 over, with the line, 8. That line is telling us that we're going, eventually it means you're going to divide, but it means that there are 5 out of 8 whole equal parts. Okay, let's look at number 2. Number 2 says, color each figure so that it represents the fractions indicated. Now I'm going to give you a little hint, because I'm all about the hints, about the hints, about the hints. 3/10. When you color in 3/10, try to color in the squares that are closer to each other. Don't just do random 3s, like one here, one there, and one there. Because when you do that, it's hard to compare them later. What I would do is choose 3 that are either 3 in a row, or 2 in a row and maybe 1 at the next column. So you can choose 3. You don't have to do the same 3 as me, but I highly recommend you keep them together. So I'm going to do the top 3. I have 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. Let's see what the book did. The book did the same thing as me. Great. Let's look at 1/3. So again, naturally, I just want to color the first one because if I ever wanted to compare it, it's easier to compare the first one. So let's see what the book did. You can, if you color the middle one, it's still right if it's all by itself. Or if you choose to just color the one on the right, that's fine as well. Yeah. Whoever wrote this book and I have the same ideas. Okay, let's look at C, letter C. They want us to color 4 out of 9. 4 out of 9. Well, I see 4 together here. I see 3 together and then 2 together. So if you want to do the top 4, you can. If you want to do like a square, you can. I kind of just want to do the top 4. It's easier. There we go. So this is a collection. I'm coloring in 4 out of the collection of 9. Ooh, I got it right again. Cool. I think my luck is going to run out on the last one. Let's see. I need to color in 3 of the 7. So for me, the bottom 3 just look easier to color. But something tells me this book did like 1, 2, and maybe the top one. I don't know. Color in your 3. And we'll see if you get the same 3 that the book does. It doesn't have to be exactly those 3, but definitely choose 3 that are together. Oh, they chose the top 3. I was so close, and yet so far away. I think you get the idea. It's really not that difficult. Practice makes perfect. So let's move on. Oh, this is going to be fairly easy. What I just wanted to do for you is I'm going to read to you the words, and you have to match what the words are to the squares that were shaded in. So I'm going to read these to you, and you can write them in your book to help you later. So 4/8. That is going to look like 4 out of 8 total parts. So look for 4 out of 8. That is A. 4/8. B is 9/12. 9/12. Go ahead and write that in your book right now, please. That way you'll have it when it's time to do your homework. C, ooh, I like C a lot. C is 8/8. Have you ever seen that before? Where your numerator is the same number as your denominator. 8/8. D says 2/6. So 2 out of 6 equal parts has been shaded. Your numerator is 2, your denominator is 6. So your fraction is 2/6. You should try saying that word, 2/6. Sixth. It tickles the back of my front teeth. All right, 5/9. 5/9. That's 5 out of 9 have been shaded. 5/9. F, 3/6. 3/6. G, 4/10. 4/10. tenths. And finally, H, 4 6. Ooh, it would help if I moved it up, wouldn't it? 4 6. So 4 out of 6 parts has been shaded. 4 6. We're good? Yeah. Okay. Now we're going to look at page 81. On page 81, it teaches us how to compare fractions. So there's a couple of things we need to review. What does it mean to compare? How do we compare numbers? How do we compare numbers? Well, if you remember, we have to talk about numbers by saying greater than, equals to, or less than. That's how we compare numbers. So, 5 is greater than 2. Because remember we made Pac-Man, and Pac-Man ate the bigger number. So 5 is greater than 2. 5 equals what number? 5 equals 5. And 5 is less than, what is 5 less than? 5 is less than, what? 25? Did I hear 25? Well, I just said it, so I heard it. So 5 is less than 25. Does everyone understand that? Because here, Pac-Man is going to eat the bigger number, 25. I hope that makes sense. So, when we compare fractions, we use the same symbols. We use greater than, equals, and less than. Back to the book. All right, page 81. Comparison of fractions. So in order to compare fractions, you really have to look at the denominator. When the wholes are identical, so wholes, they mean like the whole shape here. So you see this rectangle? It's the exact same whole as this rectangle. They line up, don't they? So when the wholes are identical and the fractions have the same denominator, do you see how they both have a 5? Because it's out of 5 equal parts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All you have to do, if they have the same whole and the same denominator, just compare the numerators. So all you have to do is compare 2 and 1. So 2/5 is greater than, there's more shaded, than 1/5. Does that make sense? Let's look. The whole is the same. They take up the same shape, the same area here. Okay, so our wholes are the same. The denominator, it's divided into 8 equal parts both times. So all we have to compare is the numerator, the 3. So 3 is less than 7. There's less shaded in than the 7 here, right? 3 is less than 7. But with fractions, you're not always going to have the same denominator. It's not always going to happen. Sometimes you're going to have different denominators. And it can get a little bit tricky, but you know what? We're going to take it one step at a time, and we'll figure this out together. 2 fractions that have the same denominator have the same number of parts in the whole. So we just saw that. However, When the holes are identical, so look here, we take up the same area, they're taking up the same space. This hole and this hole, do you see how they line up? They take up the same space. Hey, I can show you something. I can prove it to you by outlining my best. So if I outline it here and I just move it over, they take up the same area. So if I highlight, oh, not highlight, but if I, ooh, don't move it. Don't move it, Diane. Silly Diane. All right, so if I, there we go. If I move it to the bottom, they line up again. So they take up the same area. So when the holes are identical, but look, our denominators are different. So let's just focus on this one. Here we have 3 out of 4, but here we have 1 out of 2. We have different denominators. So when the holes are identical, but the denominators are different, you can represent them to compare the fractions. We can still compare the fractions. All you have to do is look how much is shaded. So here you have 3 shaded. It goes beyond this one. So we know that 3/4 is greater than 1/2. Does that make sense to you? Even though our denominators are different, 3/4 has a 4 as a denominator, 1/2 has a 2 as a denominator. You can still compare them only because they take up the same area here. Their holes are identical. That's what they mean by that. Here again, their holes are identical. Remember I showed you the hole is identical. Even though the denominator is different, we can still compare them. And now we see that 3 out of 8 whole parts is less than 1/2. And I know you're like, what? How can that be? Because 8 is a bigger number than 2. Well, yeah, but look at how the pieces are. 8 little pieces, and here we have 2 really big pieces. Be careful. They're trying to trick you, and you're not going to fall for it. Because you're going to shade in, and you're going to know, just by looking, that 3/8 is less than 1/2. Let's do a little practice. Okay. So there's thing, let's see if we can compare these. 1/2 and 1/4. Are the holes identical? Yes. They're both circles, aren't they? And they both take up the same area. So if I draw on top of one circle and I go over to the other, it takes up the same area. So the holes are identical. So if they're identical, can we compare them? Yes, we can. Just by looking, we can see that 1/2 takes up more, is shaded more, right? 1/2 is greater than 1/4 or 1/4. All right, let's look at A. Now, are the holes identical? What we can do is we can draw on it. If you have a sheet protector, one of those plasticky things, you can do this with it if you want. So let's put it over top our other one. Nope, they're not the same. So, are the holes identical? No. Can we compare them? No. Compare these fractions if possible. It's not possible, so we're not going to do it. Nope. Not going to happen. Not today. That one was easy peasy pudding pie. Let's look at B. So B says, are the holes identical? Let's check. I'm going to There we go. And I'm going to move it over. Yes, they are identical. Can we compare them? Yes, they're identical. We can compare them. So if we can compare them, let's do it. 1/3, is it less than, equal to, or greater than 2/6? 1/3. Look at the space it takes up. If you're not quite sure, you can color it in. And then move it over. It takes up the same space, doesn't it? Yeah, it does. So, they are equal. 1/3 equals 2/6. Let's see. Yes, we said, and we were right. Yes, we can compare them. We were right. And 1/3 equals 2/6. Not sure why I put so much tape. That's okay. We'll fix that later. All right. Are you ready to compare the fractions at the bottom for number 2? Now, this is pretty great because look at all of these fractions. All of these fractions have the same what? Numerator or denominator? Denominator. All of their denominators, so these two have the same denominator, B has the same denominator, C has the same denominator, D has the same denominator as 3, right? Then 5, and then 9. So when you compare these, it's going to be easy. All you need to do is look at the numerator. So 1/4 is less than, equal to, or greater than 3/4. 1 is less than 3. 3/16 is less than, equal to, or greater than 15/16. It's less than. What about 4/10 and 5/10? We're just comparing, because they have the same denominator, all you have to do is compare the 4 and the 5. So 4 is less than 5. I hope that makes sense to you. 2/3 is greater than or less than or equal to 1/3. They have the same denominator, so we can just compare the numerators. 2 is greater than 1. 3/5 and 1/5, because they have the same denominator, we can just look at the numerator. So 3 is greater than 1. And finally, the last one, 2/9 is greater than, equal, or less than 1/9. The denominator is the same, so all you have to do is look at the numerator. So 2 is greater than 1. You got it right. Amazing. Okay, if you look at page 83, quickly jump to page 83. Edward has assembled 3/8 of his mosaic. Virgil has assembled 6/12 of his mosaic. So here you're going to have Edward's mosaic, and here you're going to have Virgil's mosaic. Which mosaic is more complete? So which one has more shaded parts? You're going to notice that the holes are the same. They take up the same area, so you can compare the two. Remember what I said, when you color it in, keep the three close together, the three rectangles close together, because when you compare it to the squares, the 6 out of 12 squares, if they're all random all over the place, it's going to be hard to compare. So make sure you color in 6 of the 12 close together. It's a little hint for you. I have one more hint. If you look on page 84, you have, I use reasoning. The school is organizing a dinner show. Oh, that sounds like fun. I wish we could have a dinner show. The organizers, oh, I think we'd have spaghetti. I love spaghetti. Okay, with meatballs and cheese. The organizers must choose one of the 3 tablecloths below. So here we have 3 tablecloths. The first one is 5/12 of the first tablecloth is green and the rest is white. 2/6 of the second tablecloth is green and the rest is white. The last one, 13/24 of the third tablecloth is green and the rest is white. The organizers chose the tablecloth that has the least amount of green. You need to know what the word least means. Like not that much, the least amount of green. Which tablecloth is it? The 5/12 is green, the 2/6 is green, and the 13/24 are green. Here's my hint to you. What you should do is when you make your whole, you have to make your whole equal, right? So when you make your whole equal for all 3 of them, I recommend counting, let's see, probably 4 over, so 1, 2, 3, 4 squares over, and then 6 squares up. 1, 2, 3, 4, 5, 6 squares up, and 4 squares over. Make your shape this shape. So 4 squares, count 4 squares over, and then 6 squares up. Count 4 squares over, and then 6 squares up, roughly like this. You're going to be counting. Now the reason why is because this last one you're going to easily divide it into your 1, 2, 3, 4, 5, 6. They need to be equal parts, right? And then you can do it for 1, 2, because then you'll have 24 squares. On this one, you're still going to have 24 squares, but you can divide it into 6 equal parts because you'll be able to do like this. You can divide it 6 like this, right? 1, 2, 3, 4, 5. I don't know why I was so bad at this. Okay, 6 equal parts. And then here, you'll be able to do 4 this way. You can divide it 1, 2, 3, 4. So here your tablecloth will be going like this, and you can divide it. Oh, it was 12. Whoa, 12. So 4. Ooh, what was I doing, people? 5/12. So we need 12 here. We have to divide this into 3. So 1, 2, 3. How did I do that? We did, so we have to divide it 5 out of 12. So we did 4 across and 6 going up. So how are we going to do that? You're going to have to divide this into 12 equal parts. Do you know how to divide this one into 12 equal parts? Because this is going to be easy. We have 6. 1, 2, 3, 4, 5, 6. So here I did it 1, 2, 3, 4. You know what? Oh, you know, I'm going to be good at this because all you have to do is take out. It's great making mistakes because you always learn from your mistakes. I don't need to erase. How? Okay, so you're going to go 4 across the bottom, and you're going to go 6 down, 6 squares down. Do the exact same. So 1, 2, 3, 4, 5, 6. Okay, so you still have 6 here and 4 squares here, just like this side. But look, if you divide it into half, you're going to have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? You need 5 of those 12. And here you need 1, 2, 3, 4, 5, 6. You're going to need to shade in 2. So you know what? If you shade in, let's say, the bottom 2, make sure you shade in 5 that are close to the bottom. So it'll be easy to compare. This one has 24. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, and then another 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Look at that. So this one has a total of 12 parts because we did 6 squares up and 4 squares over. This you also did 6 squares up and 4 squares over. However, we divided it into 6 equal parts, didn't we? 1, 2, 3, 4, 5, 6. And here we had 6 square, we had 4 squares over and 6 squares up. They're always the same. However, we divided this one into 24 equal parts. And it's really going to help you when you shade them in, because now our holes are all the same. They're all based on 24 squares. However, when you shade it in, you can compare them really easily. That's my hint to you. All right, so if you're still with me and you haven't fallen asleep yet, I have a little something extra for you. Look at this. This says fractions of an area. Which flags show thirds? So here we have 6 flags. 1, 2, 3, 4, 5, 6. I want to know which one of these flags of the world shows thirds. Do any of them show thirds? So I thought, well, I knew definitely this one. This one you can see it right away. There are 3 equal parts. And if I move it over and I move it over, all the parts, yeah. So definitely Nigeria. Now I was thinking maybe this one had 3 equal parts. So what I did is I outlined it and then I turned it to see if it, look at that. I learned something new. It is not actually, that's clever. It's not actually thirds because there's a little more left over. So that one definitely isn't. Spain kind of looks like thirds, but the red part is slightly smaller. Actually, it looks like it could be into fourths. It's not the same. So Spain, not going to happen. Guyana, no. The Congo, and Chile. Nope, it was just Nigeria. That's kind of cool. So what you can do is you can think of some flags. They give us Belgium here. Belgium has 3 equal parts. Does the Canadian flag divide evenly into 3 equal parts? See if you can find another country. Yep, Belgium does. Hey, that's cool. See if you can find another country that is divided into equal parts, 3 equal parts, 1/3. Super cool. All right, so we're done. You learned all about fractions. You learned that the numerator is at the top. So if I have 1/2, the numerator is the number at the top. The denominator is the number at the bottom. So 1 out of 2 equal parts is 1/2. You also learned to compare numbers. And you learn how to compare fractions based on their denominator. So if I had 1/2 and 2/2, if both the denominators are the same, then you just have to look at the numerator. So you know that 1/2 is less than 2/2. And you learned that if you had equal parts, I'm going to try to make 2 equal parts. Okay, so these have the same 2 holes. Trying my best, people. Trying my best. So here, I'm going to choose a different color. You also learned that you can compare fractions. If their whole is the same, but their denominator is different, so here I have 1/2 is shaded, and here I have 1/4 is shaded, we can still compare them, and we know that 1/2 is greater than 1/4. And you're going to tell me, but Diane, 2 is less than the number 4. And I'm going to say, you're right. However, when we're talking about fractions, the bottom number means how many pieces you have. And if I was going to get a piece of pizza, and someone took my pizza and they divided it into 4 equal parts, like a clock, right? When you divide circles, it's like a clock. So if they divide my pizza and they say, Diane, do you want 1/4 of a pizza, or do you want 1/2 of a pizza? I'm gonna say, first of all, what's on the pizza, because if it's like anchovies, I don't want anything. But if they say it's just a cheese pizza, I'm gonna say I want 1/2 of the pizza, because I am hungry and I know that 1/2 is greater than just 1/4 of the pizza. 1/2 is greater than 1/4. Don't let someone take your pizza is what I'm trying to say. All right. I will see you next time. Stay curious, everyone.